Good morning. My name is Pedro Lorenzoni, and I will present to you two types of power generation devices development in our research group. The search for new energy sources has been the target of countless research, um, mainly due to the growing demand for energy worldwide. Several technologies have been developed with the objective of converting energy mechanics into electrical. Nano generators have been appearing in the literature as a possible solution to this demand. Thus, numerous tribo generation has been described in the literature in order to improve the performance and efficiency. Through the wide choice of materials such as polymers and metals, as well as for surface modification, which are generally based on micro or nano partners. Which leads to an increase in the contact area and consequently a better tribilifications. Devices that appear in literature or use expensive materials or use techniques that are not applicable on large scale. So the idea was to build a accessible tribo generator. Well, our devices were built in three types, with PTFE and nylon, PTFE and captain, and PTFE and BOPP and oxidized BOPP. Their arrangement can be seen in this figure here. You can see? Yes. So the construction process was carried out through a protocol that consisted of cleaning the polymers with ethanol. Later, these fasts were converted with copper or aluminum tape so that the charges induced by the triboelectrization were directed to an external surge. And then the polymers were joined by its extremities at the crescent shape. Here, we see the surface modification process performed on BOPP to improve efficiency. Here in this image. And here we can see the prototypes is ready. Three types of them. After they were had user relaxation and pressure cycles. Two tests were carried out with the turbo generation. One to measure voltage and current in open circuit, and another to charge a 10 microfarad capacitor. Here we can see the test results for each prototype. The first reached 120 volts of voltage in open circuit, as shown in this figure here. Uh, in the second figure, we see the capacitor charging curve here. Second, based on Pentaphy, reached 107 volts, in addition to a different curve of capacitors charging. And the last one, made with BOPP and oxidized BOPP, gave 163 volts in open circuit and charged the capacitor up to 3 volts, as shown in the figure on the right here. Okay. Uh, these three graphs represent the data obtained for three prototypes of each type during 5 measurements of 10 minutes and 30 seconds from the pressure and relaxation cycles, like I demonstrated before. Well, this is the tribo generation. Now, I'm going to talk about hygrogenerators, which use water molecules present in the atmosphere, which tend to form a layer of hydration on the surface of materials. When this is absorbed, these molecules help to electrify the solids with which they are in contact. Was the first hygrogenerator built in 2010 with the object of studying the phenomenon. The maximum voltage obtained when charging a 3.3 microfarad capacitor was 0.8 volts. Other devices have appeared in the literature since then, but as with tribo generators, they cannot be produced on large scale. Well, I will show you how was the process for the construction of a hygroelectric cell that was later transformed into a battery. Initially, it was necessary to prepare a graphite dispersion exfoliate, like in this image here. In order to increase the efficiency of the developed agroelectric cells, chemical modifications were made on the exfoliated graphic surfaces as shown in the picture. Several cells were made using the compounds present in this table here. Um, the ones that presented the best voltage and current results were used to construction of our battery. This cell consists of a pair of nanocomposites measuring 80 per 2 centimeters, like this image here. The craft paper faces were brought into contact in a such a way that the separation between them was made with a sheet of cellophane paper. A plastic support, approximately 5 centimeters long, was used
2 minutes.
join the cell elements. Electrical contact between the exfoliated graphite face and the external source was made using conductive wires. Here you can see the battery construction. The battery construction was built in several hydroelectric cells in disc format with a 2 centimeters diameter. For the assembly of a battery with the cells connected in series and the modified face of exfoliated graphite positive was pressed against the negative face of another cell in such a way that innumerable pairs were stacked interleaved in order to obtain a higher voltage, as shown in the figure here. So the first test performed open circuit voltage measurements with relativity humidity variation, established for 30 minutes at 30%, 60%, and 8% and 100%. Then with the setup showing this figure here, a captor was charged for 5 minutes and then circuited for 20 seconds. This procedure was done 5 times to each humidity value. And in using the same setup, the behavior of the cell during long periods of loading and unloading was also analyzed. The circuit was kept open for 2 minutes to charge the capacitor, and then the circuit was closed for 2 seconds. 90,000 cycles were performed and unloading for weeks to study battery life. Uh, these are the results for the different cells with different composites. So the best one was chosen for the battery assembly. And in this case, the one represented by the blue color here. This. And then I will present the results obtained with the battery made with 15 cells connected in series. Uh, Here we can see the the results obtained for number of cells and tension and, and voltage. Here electric current and power for cell and for a battery, with which is 15 cells in series. And long-term measurements is the 90,000 cycles of tension cycles of the battery. And uh, it's this. Thank you for attention.